The rock here has been part of a fold in the western side of the Great Dividing Range for millions of years. Other than what is about to happen, it might well have stayed in place for millions of years more.
We produce about 2,500 tonne of limestone per shift, and current reserves indicate a continuity of supply for approximately 60 years. The total length of the quarry would be about 900 metres, a depth of 34 metres at the highest point, or the deepest point, and 300 metres wide. It's drilled and blasted at the face at number 2 quarry. It's then loaded by front end loader into the haulage trucks. Transported to number 1 quarry for primary crushing to a size of minus 200 millimetre. The skips hold approximately 1 tonne each and travel a distance of approximately 5 kilometres.
This is Kandos number 3 colliery. This is our main portal or haulage road. You know, all that's both our intake and it's our intake airway. It's also the road at which the supplies are taken underground, and also it's the road at which our payload is transported by diesel loco to the surface. We're looking for somewhere around about 750 to 800 tonnes. That's our budget figure. Well, the run of mine coal, of course, it is as it is cut from the working face. It is tipped into a bin up there, and a conveyor belt transports it up onto a picking belt where some of the stone is removed. It is then crushed down to -1.25 inch, into a bin, and from there it's taken to the cement company for power generation and cement manufacture.
This is a Dun Swamp Dam, or known as the Dun Swamp Dam, was built early 1930s. It has a wall height of about 49 feet and approximately 260 feet in length. And it holds something like 317 million gallons, and it backs up for approximately 3 miles. We release the water over the spillway or from the valves at the bottom. It goes approximately a mile downstream, where we pump out approximately 12,000 gallons an hour.
Three essential elements, all in local proximity, all being harvested daily as they have for 70 years. Limestone, coal and water. Together they are a blend for the success and survival of the isolated town of Kandos.
We manufacture a Type A grade of cement here at Kandos, and we believe it's the best Type A cement that's available within Australia. APCL itself, though, has other operating facilities within Australia. We have two other operating units down in Victoria, one at Geelong and one at Traralgon. And we also market other suppliers' products. For example, Anoda Cement in Japan supplies with a white cement, and we supply customers in turn with that product as required. So whilst at Kandos we only make one cement type, APCL's marketing arm are able to supply the customer with whatever he requires from a number of source locations. We also have distributed throughout New South Wales and Victoria depots to service our customers.
The new APCL Clyde Bulk Cement Depot was opened in 1980. It has a total holding capacity of 8,000 tonnes. Loading rate is 250 tonnes per hour per spout. A 25 tonnes road tanker can be loaded in just 6 minutes. As each tanker leaves the Clyde depot, it passes through the washing station as part of the environmental protection, which is a special feature of this depot.
Directly behind me we have the spray pond, which is the cooling water for the turbines. The building behind that is the powerhouse, where we produce our own power for our cement works. I'd say at the moment we produce about 70% of the power required. From here we distribute it to the factory at different substations, number 1, 2 and 3 substation. These do supply the various sections, the raw department, kiln department, the crushers, all these sort of things.
One of the things that separates us from the ancient way of making cement is the fact that here at Kandos we operate on a 7-day-a-week, 24-hour-a-day basis, as do other modern cement plants, but we make a very tight and critically controlled quality product, very well accepted in the marketplace, particularly from the point of view of our ability to supply. The art of making cement goes back many thousands of years. We here at Kandos have been practicing that art for the last 70 years. It is a very simplistic art form. We have prepared a schematic to show you exactly how the cement is made. Limestone is transported into our plant at Kandos via 2 aerial ropeways. We bring in approximately 2,000 tonnes a day, and the buckets are tipped, discharged into this gantry which holds approximately 4,000 tonnes. It's then drawn through bottom feeders into the first of 2 gyratory crushers. These crushers reduce the stone in size first from 75 millimetres, then down to approximately 25 millimetres. A conveying system then transports the limestone to a blending bed where the limestone is laid down in layers. This layering effect is induced to bring about an effective blending process. Reciprocating feeders from underneath the blending beds then transport the material to a series of hoppers containing limestone, ironstone and low-grade stone. This is also the area where our laboratory is situated.
This building is number 2 laboratory. We operate on a 7-day roster system, 24 hours a day. Now behind me we have what we call the mixing station. We have the first one is limestone, the second one is low-grade limestone, and the third one behind me is ironstone.
The mix controller in the laboratory analyses the quality of the limestone coming in on an hourly basis. He then makes his alterations to these scales in the form of additional subtraction to materials to achieve the desired mix aim. The material is then transported from these Avery weigh feeders into our raw milling complex. A raw mill is basically a steel cylinder full of large steel balls rotating at approximately 17 revs a minute. The balls inside form a cascade pattern. The material is choke-fed in one end with a fan-induced draft. The fines going on to our blending silos, the coarse material being reintroduced via a separating system. The material is blended in silos and then fed into the back of our kiln. This rotating kiln is lined with refractory brick. The material enters the kiln at approximately 700 to 800 degrees centigrade via a heat exchanger, and the discharge temperature is approximately 1500 degrees C.
In the kiln control room, the burning process is precisely monitored with complex instrumentation. A 24-hour watch is maintained to assure constant quality control.
Product from the kiln is known as clinker. The clinker then drops into a moving grate cooler where it is cooled for ease of handling. Again, this material is tested every hour by our laboratory mix controller, and that is put into a large clinker storage shed, the positioning of the clinker depending upon the outcome of the chemical test. At this point, we extract from underneath the clinker shed via vibratory feeders, and we add in approximately 5% of gypsum. The purpose of the gypsum in the clinker gypsum blend is to act as a setting agent. It's worthwhile to note that at every stage of manufacture, this is the only time at which we introduce a material that is not locally won here at Kandos. This blended material is then ground in our cement mill. This cement mill is a unique mill in Australian cement industry. It is the only centre discharge mill available in Australia. It differs from our raw mill insofar as the material is fed in at both ends, met in the middle, discharged from the centre. The fines are then sent on to our silos. The heavy material is then reclassified, reground, and the process continues.
Some 400,000 tonnes of cement is dispatched annually from the Kandos plant. Half of this is transported by rail. The other half is distributed by bulk road tankers or in the familiar Kandos bags.
If you make concrete using Kandos cement, I think you can be guaranteed or rest assured that you're going to have a product which is sound and stable, doesn't crack for years. It has that reputation. And being here locally produced, it has a very cooperative and well managed but a entirely concentrated workforce here at this work. So you have very few problems in making the cement. And some departments within this works have gone for 13 or 15 years without an accident in their own departments. And that's fantastic. Well, it costs some money with teaching and with practices and safety equipment. But when you look at that as against the cost of accidents and compensation, no, if you get a good safety record, your total costs come down. It's very effective.
We have within our sales force technical service representatives who are capable of going out, talking to the customer in terms of problems that he may have with his own clients, and also able to start off to help the customer in the development of new products, new mix designs, new jobs. So we feel that with this competence that we have within our sales force, it is of great advantage to us in our selling effort.
Customer service, quality control, reliability of supply, important to any trader in the ancient art of cement manufacture.
The competitors have this, but we like to think that we do it better.
The basis of the structures of civilization has, for thousands of years, involved the reshaping of the rocks and clays of the earth and the use of cement to bind them permanently in their new form. A significant part of the cement of these structures came from the limestone, the coal, and the water, whose special qualities were blended at Kandos.